Hello everyone, welcome to my U Programming Club. Today we will be solving another daily read code challenge, and the challenge name is Coin Change Part 2. So the challenge statement goes like this. You are given an integer array coins representing the coins of different denominations and an integer amount representing the total amount of the money. So you have to return number of combinations that could amount up to that amount. If the amount of money cannot be made up by any combination of the by using the coins of the coins array, you should return 0, and the number of quantity of coins of each type is infinite. So also, it is being stated that it is the result of your solution is guaranteed to fit in 32-bit integer. So let's look at the constraints. The length of the coins array is of order 300. Value of coins in coins array uh, is of order 5,000. All the values of coins are in the coins array are unique, and the amount of is order 5,000. So how you will be able to solve this problem? Let's consider the brute force way to solve this problem. It will be to generate all the combinations. Now for every coin, every type of coin, you are having two options. Either to include it in present combination, or exclude it from present combination. So there will be two choices. For every coin, there will be two choices, and how many number of times this two choices will be made. It will be maximum of length of coins array, or uh, what is the sum called here? I think it's called amount. Yeah. So the amount divided by minimum of coins, minimum value from coins array. This will be the number of times these two choices will be made. So the overall number of operations will be 2 raised to power. Let's call this number as half. Half. So it will be this, and so this can be. So for example, let's say the amount's maximum value is 5,000. So here 2 raised to power 5,000, and minimum value of coin can be 1. So divided by 1 is equal to 2 raised to power 5,000. So operations can be as large as 2 raised to power 5,000. So clearly these number of operations, clearly 2 raised to power 5,000 is greater than 10 raised to power 8 operations. allowed in 1 second. Those of you who are not familiar with what I am talking about here, uh, I will be providing a link of an article describing how the time complexity of a separate solution varies with input size. Link of an article describing this will be provided, so you can check that article out, and then you will be able to understand what I am talking about here is. And right now, what I can tell you is, in 1 second, you are allowed to perform 10 raised to power 8 operations. Your solution is allowed to perform these number of operations, and if the number of operations, the actual operations that your program is performing, becomes equal to 10 raised to power 8 operations or exceeds this number of operations, then your solution will get TLE, time limit exceeded, and it will not be accepted. So we have to optimize on the brute force in order for our solution to be accepted. To get AC, we have to optimize our brute force. So I will be doing so. If you consider, let's say you are currently at this sum x, you are asked what will be the number of combinations. What are you are asked? What will be combinations of points that can amount up to x sum. So, if you are asked this question, then what will be the choices of coins that could have led you to this sum? So, if let's say the sum is x, what will be the choices of the coins that you would have been made in the past that would have made you to land at this sum? Those coins would be the coins whose values are lesser than or equal to present sum. For example, let's say a present sum is 3, and the denominations of coins are like this. So let's say you were at some previous sum, and you were to have make choices among these denominations of coins. So what choices of coins could have lead you to this current sum? uh, those denominations would have been 1 and 2 only. Since 4 is greater than 3, if you subtract 4 from 3, it will be -1, which is a negative value. So the amount could not be negative. Amount is always greater than 0. You can check, it is either equal to 0 or greater than 0. It is not negative. So you could not have come to this current sum from a previous sum which is negative. This previous sum value should also always be either greater than 0 or equal to 0. So only those values, only those points whose values is lesser than or equal to the present sum. What are those coins? This and this. 4 will be not be considered, since present sum, which is 3, is lesser than the this denomination's value. So I hope you are able to understand what I mean to say by only those coins whose values are lesser than or equal to the present sum. So Then based on what coin that could have led us to the current sum, we can find which previous sum could have led us to that present current sum. So accordingly, let me quickly change to a new slide. Let's say you are given the denominations 1, 2, and 4, and the current sum is 3. So we are we want to know what were the previous sums that could have led us to this 3. So it will be nothing but 3 minus 1 equals to 2, 3 minus 2 equal to 1. So these would have been the previous sums that could have led you to this current sum. Let's take them 2, 1. Now, whatever we decide to, let's say we decide to add a coin of denomination 1, and it would have lead you to the current sum, which is 3. Now, let's say you here decide to add a coin of denomination 2. It will lead you to current sum 3. So these are the previous sums which will be contributing if we somehow know, if we somehow know what will be number of combinations possible for each possible previous sum, then what will be the number of, then what will be the number of combinations possible for current sum. So what will be the those number of combinations? Let's say the number of combinations possible for a particular sum. Let's say this is a particular sum, and this denotes the number of combinations possible for some. Uh, let's say it is stored in array called results, and so what will be the value of result of current sum? It will be nothing but result of, let's call this uh, previous sum 1, previous sum 2. This is previous sum 1, this is previous sum 2. It will be result of PS1 plus result of PS2. So accordingly, what would have been the number of possible combinations that could have led to previous sum 1 plus previous sum 2 will be the number of possible combinations that could amount up to current sum. So I hope till now you are able to understand. Now let's move that back to that previous slide. So all the points in this slide are being discussed. So yeah, that's pretty much it. Now for each denomination of coin, denomination of coin, we will be checking the contribution of number of choices that it will make to a particular sum. Number of combinations. So let's quickly dive into the coding part. There you will be able to understand in a much clearer way what I am saying here. Now let me quickly zoom out so that you would be able to see a larger portion of a code. Fine. Yeah. So we have, please ignore the comments for now. I will be telling you what these are for. We have stored the size of the array coins in a variable size, and we have formed a array that will, this array is similar to this result array, which will be storing the number of possible combinations for a particular sum. Number of possible combinations for a particular sum. So its combination count, the name is self-explanatory, and then for each coin, each value of each type of coin are checking its contributions in terms of number of choices, combinations it will generate for a some value. And what will be those some values? Those some values will only be those values which are greater than or equal to the value of coin. So we will be starting from the value of the coin until the amount. What is the amount? Amount is the amount that is asked in the question, for which we have to return the number of combinations that could have that would sum up to that amount. So till the amount given in the input, we will be starting from the current amount from the coin's value. So at least the current amount should be able to uh, should have been equal to the value of the coin, so that it could get the contributions from that coin in terms of the number of choices that coin would generate. So this is the same thing that I have been talking about. So what will the contribution of the current coin? This is a previous. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the problem solution. Uh, this is nothing but the previous sum that could have led us to the current sum, or say current amount. Previous sum, or say previous amount. Now, for that previous amount, its contribution will be considered. What will be its contribution? It will be combination count of the previous amount, or say country. So it will be and we will be adding all such contributions. All the contributions we will be adding. For example, here we have added two contributions that were possible from two previous sums. So for each previous sum, we will be adding to the current sums combination count. So that's pretty much it. And at last, we will be returning the combination count of the amount that was given in the input of the function. This actually I have sorted the word out. It was initially amount. It was this. For my convenience, I sorted the word out. So yeah, that's pretty much it for the solution part. Now you may ask, why are we considering loops in this particular way? Why not take loop in this fashion? In this fashion, look for the current amount and check for the number of check for each coin which will be adding contributions to the number of choices or combinations it will generate. So why not form nested loop like this? So the reason for that being, if you want to check what is the reason, you should remove the comments and print these statements. These printing statements you should remove are being commented out. You should uncomment them and you can have a dry run of the solution. So for the dry run part of the solution, it will be this. So here what happens is this is for the this type of loop in which first loop is the current amount and the next loop is the value of the coins. So what happens here is the contributions which each coin would be making in the number of choices generated will be added more than once. What I mean by this is if you remove all the comments, you will get this output, and you can see here for sum 3 you are having here two number of, for actual result you are having only two combinations, and for the wrong approach you are having three number of combinations. So somewhere a choice of a combination was added extra or was added more than once, so it will result in a wrong answer. So this is the reason why I have chosen this particular order of the nested loops. So if you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. So in nutshell, this is the logic of the problem, and it will what will the number of times this solution will be running. It will be nothing but size of the coins array. Uh, Let me quickly take another slide. It will be what will be the time complexity? It will be the size of coins array for this loop, and for this loop it will be the amount, order of amount, maximum value of amount, and the size of coins array is of order. Let's move to the constants. So size of coins array of order 300, and the maximum value of amount can be 5000. It is 5000. So what will be the number of operations? These will be equal to this value, which is lesser than the 10 raised to power 8 operations. So you will get a TC. Thank you for watching. Thanks.